Perfect. So we can definitely kickstart this. I guess nothing's better than starting a meeting off with a bit of technical difficulties. I think most of us have that on our day to day. So I just want to welcome everyone once again to this community of practice, our first one for sustainable concrete in 2025. It's crazy to think that we've been doing this for a couple of years now, which is really good. As each meeting we have, I think the participation is very much increasing, which is really good. That's the main purpose of this community of practice. So once again, I would just like to welcome everyone. For those who haven't attended a community of practice, I always like to start off with the fact that we want this space to be a very much informal educational space whereby we can really talk about what's happening in the academic world and what's happening in industry, and just to ensure that we're aligning with one another and just really showcasing our collaborative work. So I guess the main purpose of the community of practice, specifically for this one around sustainable concrete, is to really understand, I guess, what current challenges we have, both in the academic world and in industry. How do we address those challenges, and what current projects are we working on, I guess, to overcome that? Just to quickly recap on the previous meeting, we spoke about the circular economy. We mentioned, well, I guess we spoke mainly about, I guess, some of the objectives and the main drivers around circular economy. We also spoke about the pathways and how to overcome that, and some of the limitations around standards and technical guidelines that we currently have in the industry. Without further ado, though, Professor Voet kind of already mentioned this. I'm stepping down as the chair for this community of practice. I thought it was time for everyone to see a new face, for new ideas. And so we have our new chair, Aaron, who's going to do a phenomenal job. Just to give a bit of a background on Aaron, he has over 8 years of combined experience in both the academic and also the industrial settings as a civil engineer. He's also an operational specialist and also a material scientist. Aaron's goal is to create a sustainable and durable construction products that support modern and also advanced production technologies. So I will hand over to Aaron, and just for this specific community of practice, I'll assist with chairing, but for all future community of practice, that will all be Aaron. So I'll let Aaron introduce what we're going to be talking about today.
Thanks, Olivia, but you're not getting away just like that. You need to sit until the end of this meeting before we let you go. I've been telling to Wood, this is a huge boots to fill. You have done an excellent job, Olivia, and I think I'll try my best to do the best I can. And coming to today, we are going to talk about reclaimed paint in concrete. So the beneficial use of reclaimed paint in concrete. So the first question is, what is reclaimed paint? And understanding it in the large context, understanding the value proposition of the reclaimed paint in concrete, and the technical challenges and the industrial challenges, scaling up, and all those things. We have two excellent speakers with us today. Is Rachel Roberts from Paintback, and also Professor Jay Sanjayan, who's a professor at Swinburne University. And we have a few housekeeping rules before we get this kicked on. We'll let both the speakers to go first. Each has their presentations, and then we can go on to questions. We welcome the questions in the chat box. So if you have any questions, raise hand and jump in. We are happy to take questions as it comes. And I'll let Olivia introduce the first speaker.
Perfect. Thank you, Aaron. Our first speaker is Rachel Roberts from Paintback. With over 8 years of experience in sustainable leadership, Rachel is currently the General Manager for R&D at Paintback, which is a national scheme that collects and treats waste paint and packaging. Rachel is passionate about the advancement of the circular economy, reducing water emissions and resource consumption. She has a strong background in chemical engineering, project management, and data analysts. Rachel is committed to delivering great projects that the environmental and the social benefits are at the forefront. So please welcome our first speaker. And just to reiterate again what Aaron said, please leave your microphones on mute. Thank you. Over to you, Rachel.
Thank you, Olivia. Thank you, Aaron. Can everyone hear me okay? Good, good. So I'm here to talk about Paintback, but more contextually, our current active project under the SmartCrate CRC with Jay's team over at Swinburne. So what is Paintback? Our mission is to ingeniously build a better future with Australia's unwanted paint and packaging. And as you can imagine, there's actually quite a lot of unwanted paint and packaging. So we were established in 2016. We're an industry-led voluntary product stewardship scheme. So you can see on the bottom of this slide, we're led by the major paint companies in Australia. And essentially we cover about 90% of all architectural and decorative paint sold in Australia. We're headquartered in Victoria, where we're also building a large-scale facility to repurpose paint for new products, including the product that Jay and Nan are researching at the moment. We essentially service 85% of the national population by distance. So that means about 85% of all Australians have access to a Paintback collection point. Our target to divert landfill is 90%, which also includes the packaging. So we accept water-based paint, solvent-based paint, which is housed in either plastic or steel containers. We've got good acknowledgement with Australians, particularly those that are pretty heavy on DIY and trade painters. So 1 in 5 of Australians know of Paintback and the scheme. And half of the people who have painted in the last 12 months have used the scheme to return their unwanted paint. So we're very proud of what we've essentially established for this very difficult to find reuse stream. How does Paintback work? So DIY, so you and I, when we're doing a bit of a renovation project or a refresh coat of paint, we essentially take our unwanted paint to a Paintback site. Those are typically council transfer stations, although in New South Wales they also offer pop-up events. The unwanted paint and packaging is stored at the collection point and we pick it up. We then essentially transport it to an aggregation point where we sort by the different types of paint. So predominantly we receive water-based paint, but we also receive a healthy amount of solvent-based paint through the scheme, which we segregate because they have different end-of-life pathways. Our solvent-based paint at the moment goes to cement kilns as an energy replacement. So it essentially replaces coal as the energy source for clinker production, which is great and ties in really nicely with SmartCrate CRC. And our water-based paint gets diverted to different end-of-life uses. And we're always actively researching higher order uses. So something that's really important about our R&D project is we're not trying to squirrel away the paint. We are trying to find a better use for it, which leads to better performance and environmental credentials. To date, so since 2016, we've actually just ticked over 60 million kilos of paint and packaging collected. So that's a lot. We've provided access to over 400 pop-up mobile collection events with partners such as Bunnings, Mitre 10, local government transfer stations, and state governments. Across Australia, we've got 169 collection points. And we're funded through a levy. So we're a not-for-profit that's funded through a levy of every litre of paint sold, which is 15 cents. So that 15 cents goes to Paintback to operate the scheme, but also to pursue research and development projects to unlock new uses for the paint that we collect. Our collection network is vast. So as you can see, we basically cover all the major collection at the major population centres across Australia. And there's some photos of happy returners of paint from our scheme. So R&D is really at the centre of what we pursue. Whilst it's all well and good to collect material and divert it from landfill, we do really need to identify good uses for that material. So our project with Swinburne is focused on the water-based paint stream and whether we can use that in concrete. I'm I'm very lucky and thankful that I've got an R&D advisory committee, which is full of experts from cross-discipline engineering, and they provide the steer on research projects. Essentially, you know, do they make sense technically, but also do they make commercial sense? So for us, it's really important that anything that we develop does yield a commercializable outcome. So we like to see it out in the wild and beyond the lab. We do have a pilot plant. So last year we had a pilot plant at Manufutures Deakin Geelong, which is really important for us to be able to produce material that's representative of what we're building in our larger scale plant. So our project was SmartCrate CRC, and we're very thankful to have SmartCrate support and the researcher support in unlocking a better use for paint. But we essentially want to determine, does paint offer any value adds for concrete? Can it displace any materials, and can it improve any of the performance characteristics, including durability? We're then looking at commercializing the research with good industry partners that have a shared vision to unlock sustainability and performance enhancement to concrete mix designs. And I won't steal Jay's thunder because he will hone in more on the research and what we've discovered to date. It's very exciting. I'm sitting in our new plant, which is dubbed PACE HQ, or Paint Circular Economy HQ. So one thing that's quite vital to the success of commercializing any research project, particularly the one that we have with SmartCrate, is being able to produce the material en masse and make sure that it's consistent. So we're just in the throes of constructing a large-scale plant that will essentially take all of Australia's unwanted paint and then separate it from its packaging and allow us to divert all that material from landfill through different avenues. We also do have paint as paint at the moment. So through that, we essentially avoid 15 kilos of CO2 per 100 litres of recycled paint. So it avoids the requirement to extract resources to make brand new paint, but also the imported materials. So it's actually really good to recycle paint because it is quite a carbon intensive material to produce. Unlike other product stewardship organisations, we're quite lucky that we do have really strong industry and sector support. And we've essentially learnt that by becoming part of the supply chain for recycling paint and packaging, it means that we can really control the quality of our feedstock a lot better and understand where it's coming from, but also what applications it's ending up into. Here's a bit of a circular economy diagram. So the circular economy underpins everything that we do. We really try to find beneficial uses for all the materials that we receive beyond water-based paint. We utilize the solvent-based paint as an energy source, and we are looking at different R&D projects, including the one with SmartCrate CRC for the water-based paint. We recycle our plastic material into pails, which you can purchase a 4-litre bucket in Bunnings using the material collected from the scheme. We're always looking for industry and research collaborations, so I'm quite fortunate that this room seems to have quite a few industry and research people in attendance. So if you're interested in the research that we're promoting today, please do get in touch, whether from a research perspective or from an industry perspective. We're always looking for problems to solve, and I do believe that paint, being such an interesting material, can lend itself to solving many of the industry problems, particularly in the concrete sector. Thank you.
Thanks a lot, Rachel. That was a really good presentation. It's very simple, easy to understand, and that's how we want to have these presentations running. And the second speaker is Professor J. Sanjayan. He is the director of Swinburne Center for Sustainable Infrastructure and Digital Construction. He specializes in concrete materials technology and has conducted extensive research works in 3D concrete printing, digital automation, low carbon, geopolymer concrete, incorporation of waste streams for value adding in concrete, the waste paint is one of it, and use of phase change materials in construction, etc., etc. Jay has published over 500 publications in these areas, and during the last 30 years has around 39,000 citations. And I just checked it before the meeting, Jay, and you are at 105 H index at Google Scholar, which is a huge thing if you think about academia. He's a fellow of Engineers of Australia and an honorable member of the Concrete Institute of Australia as well. Please welcome Jay. The floor is yours.
Thank you, Aaron. Can you see my slide?
Yeah.
Okay. So yeah, thanks. Following from Rachel's introduction about the reclaim water-based paint. That's the word, the terminology we use. So the project aim is to find a value add use for the reclaimed water-based paint. We call it RWBP in concrete. So because of the time limitation, I'm just going to show some selected results of the research that we have been doing now for more than a year. So this particular slide shows 5 different concrete mix designs. So if you look at the first column, that's where the reclaimed paint, we added 0, that's the reference, and then 4 liters, 10 liter per cubic meter of concrete, 20 liter per cubic meter, 30 liters. So that's the 4 levels of reclaimed water-based paint dosage. And you can see at the top the cement content is about 330, which is a typical concrete. It's got 25% fly ash, coarse aggregate about 1130 with 20 millimeter and 40 millimeter aggregate, and fine aggregate. And the fine aggregate we need to change between the mixes, because this the water-based paint has, let's for example, you take 10 liters of water-based paint, that's the third mix, and out of the 10 liters, there's about 7 kilos of solids. So we take off the 7 kilos from the sand, the medium-sized sand, and then the rest we take off from the water. But at the same time, the water, we reduce it to balance the slump. So when we add the paint into the concrete, the workability goes up, so we can pull off some water to compensate for the to maintain the slump. So the water binder ratio effectively decrease. Here you can see the amount of air that goes into the concrete when we add water-based paint. And that is mainly the reason the slump goes up, because we're introducing air into the system. So this is the amount of air after we cast into the concrete. So the first one, you can see there's a slight increase in the air in the concrete if we cast later, mainly because the slump is decreasing, so they introduce more air. But with the waste paint, there's a slight reduction in the air, because the workability is good because we got a lot of air, but but the air collapses with time, so we have a slight reduction in the air content with the paint in the concrete. So there's increase in we are increasing the dosage when we go towards the right, and the air bubbles collapse. So that's why there's some reduction. So as we can guess, I think it's better if you focus on the last column, 28-day strength. This is a 42 megapascal, 40 megapascal strength mix design. but despite we pull off some water, the amount of air introduced is so high, there is reduction in strength. So that is an issue. But we put that issue on the side, and then let's go and look at carbonation, which is where the exciting results are going to come. So let's look at the carbonation. What we did is accelerated carbonation test. So we increased the, this is following the international ISO standard. So basically we increased the carbon dioxide concentration in the chamber to about 3% with the temperature 22 degrees, relative humidity 55. And the controlled concrete, we get a 5 millimeter carbonation depth after 28 days. And after 70 days, we get 13 millimeters. So that's equal to maybe 20 years of carbonation. So, but when we did the same with paint after 70 days, the carbonation effectively didn't happen. You can see with the 4 liters, 10 liters, 20 liters, 30 liters, the depth of carbonation was, we could not detect anything. So we did some pH tests, because what we can see is a slightly reduced color, because the uncolored area at the top, that is carbonated. The colored area is not carbonated. But with the paint, the concrete containing paint, you can see it's not a clear cut. So we did a pH test. So you can see that the carbonated areas, or the color area, it's between 9 to 10 pH, 10 to, when we increase the paint dose, the pH is high. But it's not as high as 11.5. 11.5 is what we have in concrete when it's uncarbonated. So there's a slight reduction of pH, but not as much as like the normal concrete that's gone down to 7.5 to 8. So the pH is remaining high, but not at the same level as 11. So the carbonation depth, even though we say is no carbonation, but there's a slight reduction in pH, but it is not enough to cause corrosion of steel, I must say. So the carbonation depth decreased with increasing dose of paint. That is the conclusion from this part. But where we can use this result. So we've had some discussions with some concrete suppliers, and they said they're working on this high supplementary cementitious material concrete that is now, because of the pressure to reduce carbon emissions from concrete. Basically, that means we need to reduce the amount of cement in the concrete. So here you can see the top curve. That is the fly ash. If you keep increasing the fly ash from 0 to 50%, the carbonation rate increase very significantly. But if you the next one in line is silica fume, which and then is the limestone, and then slag is perhaps one of the best performing, but it's still, we have 2-3 times higher carbonation when we add supplementary cementitious materials to concrete. So so that is one of the reasons that we cannot increase the supplementary cementitious material beyond a certain low proportion. One of the issues is carbonation. So maybe we can use paint in the concrete to increase the carbonation resistance. So that might be a good value add proposition for the reclaimed paint. We also did some work on sorptivity, and you can see the absorption period up to 56 days, I think we did. And the when we add paint, the absorption, water absorption into the concrete decrease. That's what you can see from this slide. And drying shrinkage, that's another big issue in often in concrete. And we can see beneficial effect, see from 0 to 4 liters, 10 liters, 20 liters, 30 liters. This is a, we measured shrinkage up to 70, 80 days, but normally it's only required up to 52 days. So you can look at the 56-day results. You can see the results, the 40 MPa concrete had 500 microstrain, reducing all the way down to about 300. So it's a good concrete to start with the 500 microstrain. We can still get a significant reduction in shrinkage, which is another great benefit. So we have shown carbonation resistance, reduced water absorption, which link to perhaps the chloride resistance and other any bad materials that go into the concrete to attack the concrete. They have water as their transport agent. So if the water is penetrating less, that's going to be beneficial for the durability, regardless of what the attack is. So what are the reasons and mechanisms for this is important to understand. So let's look at a concrete in under microscope. We have open pores, and also we have closed pores. The closed pores is where water cannot get in. So and this capillary force is defined by this equation. You may not have come across this, but one of the important factor is the contact angle between the solid and the liquid that defines the capillary force. The others remains constant regardless. So and the other, so the R effective, that is the parameter that's at the bottom, that's related to the porosity. It's this, the radius of the pore. So we measured the total porosity using scanning the concrete and doing an image analysis. That method has become quite popular. That measures the closed porosity and open porosity. And the open porosity is measured by water immersion. So we immerse it in the water and calculate how much water is absorbed into the concrete, and the water only gets absorbed into the open porosity. And this is the pore size distribution we got. And you can see when we increase the paint dose, the pores increase, which is the large size pores. And so you can see the total porosity increase with increasing paint dose. But the most interesting thing that we noted was that if the total porosity increase with increasing paint, but the open porosity drops, which is unusual because normally the open porosity increase, total porosity increase. They both increase the same way. But with the paint, we observing an opposite effect. It's the same, it's a similar graph here. You can see when the air content of the fresh concrete increase, that is with increasing paint. The total porosity, which is the top curve, that increase, but the closed porosity, the total porosity is the top curve, and the open porosity, which is only part of the total porosity, which is actually decreasing. Again, if you look here, the curve with the circles, which is the total porosity increase, the strength decrease. But at the same time, the closed porosity increase. So this is an anomaly we found, and that might give some explanation. In addition, we also measured the contact angle, that is the angle between the water and the surface of the concrete, using our equipment that we have at Swinburne. And that's the angle, it's called the wetting angle between water and the concrete containing waste paint. And you can see here the contact angle, the bottom curve with 0 liters, that's the contact angle with the penetration period. With time, the angle reduce, and then the water getting absorbed. That is the first picture you see on the left-hand side. But with increasing amount of paint in the concrete, you'll see that angle decrease. And that is the major reason, because the angle increase, this factor decrease, because that's the cosine of the angle. So that means the capillary pressure decrease. So in conclusions, we can say that the water-based paint increase air, that lead to reduction in strength. Open porosity reduce with increasing paint, that subsequently have water penetration, water absorption, drying shrinkage, and also the increases the contact angle, that has effect on water absorption and drying shrinkage. So the advantages are drying shrinkage, water absorption, and carbonation rate. The main issue that we need to address is the strength reduction and the air content. So we have done some other research to look at the mixing speed, and the mixing speeds tend to, if you have a low mixing speed, we have low air. Also, if we have finer aggregate grading, that also increase the air, so we need to make it to coarser grading. Water binder ratio decrease, the air decrease. But I think the main work we're focusing on is using deformers to destroy the air in the concrete, and that so we have tried different deformers, and we have been successful in achieving that. So I think the discussion we want to have is about the carbonation resistance and how we can find potential uses for the paint in concrete industry. Sorry, I went took too much time.
That's perfectly fine, Jay. It's a great presentation. And as soon as you say carbonation, and then when the pH is above 11 or about 10, close to the surface of the concrete, as soon as people see there is less cover for the rebar, Where I work in the precast industry, they just love it. They just want to have some taste of it. So that it looks really interesting, the results, and from that we can I want Olivia to join me and we open the questions to the floor. I have, because I have the privilege of being the chair, I have a few questions and I'll start with Rachel. Rachel, so I for once believed waste paint comes in different colors as in paint. So I think that is not true. Like, what are the common misconceptions you had about paint recycling and paint back? How does paint back address them?
Yeah, whilst color, obviously paint comes in a range of colors. Typically, we receive mostly white because, as you can imagine, most people paint their ceilings white. En masse, there's a lot of white paint in circulation. And one of the, I guess, common questions, particularly around these sorts of uses of paint, is will this affect the color of the concrete? And the answer is no, because when you blend all the paint together, it tends to be almost like a concrete grey. If you can think of an average color, it is concrete grey. Yes, that's probably the most common misconception, is we get very different colors every time we blend and treat, but essentially because our incoming materials pretty stable, you do get the Dulux Pantone color of the year that sort of blips, but it's all washed out by the sort of more beigey whites, greys, some greens as well are quite popular. I think as well, there's even though paint's everywhere, not many people know what paint actually is. And on Jay's note, paint is very much made up of polymers and pigments and titanium dioxide and about 50% water, which is why you get that water reduction ability in the concrete. But to be fair, most people don't think that paint is a polymer, and I think that's why it lends itself to being quite interesting in applications like concrete.
Yeah, probably another question for me as a follow-up question on the intake of waste paint is: are there any contaminants during the collection, and do we need to process it?
Yeah, so we do in our pilot plant and in our scale-up plant, we do essentially sort and inspect, but also run it through filters to make sure that we aren't getting things like brush hairs end up in paint a little bit. As you can imagine, people lose a couple of their paintbrush hairs in the paint, and then they sometimes make their way back through the scheme. But contamination's not that high. I'm from a recycling background where I used to accept people's yellow lidded bins from the curbside, and that would have, batteries and those sorts of things. I think paint's a very easy thing for people to segregate. It typically stays in their shed in its original container, so you can read the label and sort of understand what's in the tin. But we do occasionally receive paint accessories through the scheme, but it's not really a problem.
Any questions in the chat?
Let me keep an eye on the chat as well.
Hi, I have a question.
Hello, yeah.
Hi, my name is Tracia. I have a question. So firstly, thank you to both speakers for presenting, really interesting. My question is around any off-gassing that might be a concern in using paint, because I have heard, fly ash, there's been some concern around VOCs being emitted in concrete. So do you have the same concern for paint being used in concrete in terms of off-gassing? That's my question.
Sorry, say it again.
I'm happy. Yeah, I'm happy to have a crack.
Yeah.
It's a really
Thanks.
good question. Most paint is formulated now to be low VOC. So, once it's set, we do find it's very inert. Maybe at point of mixing application, there may be, some release, but nothing beyond what you would get from painting a wall in your home, which is now safe with current formulations on the market.
Okay, so what about like the concentration? Because if you're using a large amount, it's typically a bit more concentrated than, as you said, paint that you'd use in your house. Is that a concern at all?
I don't imagine so. So I think Jay's research is sort of capped at 30 litres per cubic metre. So that's still just 3% per cubic metre of concrete. So it isn't, an enormous amount of paint that's being used when you think of the volume of concrete being poured. So yeah, it's not necessarily a concern. The other thing is through EPA, with any sort of products that we utilize reclaimed paint in, we do have to perform very thorough testing before it's available on market in each jurisdiction. And we've done quite extensive tests for a separate project in concrete, looking at leaching under very harsh acid conditions to see if the paint would essentially contaminate the nearby soil or waterways, because that's always a concern for the EPA. And we found that the paint actually binds the concrete more than the control, because the polymers in the paint actually acts as a glue. So it almost holds everything together a bit better.
Okay, interesting. Thank you so much.
You're welcome.
Yeah.
Good question.
Yeah, just also I might just add, we use paint in how I'm sitting in a room. It's painted. The plasterboard is painted, so it must be safe enough to be used like that. There's a question in chat that it's interesting that you increase the quantity of the paint, the porosity increase, which is correct because of the air. When the porosity increase, then the carbonation should increase, because that is normally the case. But we are observing the opposite. So this is something we are still working on, but I think the reason is something to do with the wetting angle and the water absorption and the porosity. Because if we decrease the porosity further by using deformer, I think we're going to see even higher carbonation or better carbonation resistance. So the thing is that despite the porosity increase, we're still seeing a carbonation reduction. That is the message. That is the results we are seeing. It's another, could you please comment on the consistency of paint's properties and other factors that might affect the properties, such as age and supplier brand variation? That's a very good question, because we have done about 4 or 5 different batches over the year. There are some variations, but not significant enough, but that needs more work, and I think Rachel should also comment on that. But I just want to make a point that we use fly ash, which is a waste stream. Slag is a waste stream, and they have variability. We have aggregates, which is a natural product, which has a significant variation. So that we accommodate them by having concrete mix design with the target strength, a mean strength, and a characteristic strength, and there's a standard deviation, which allows for the variability of the materials. So I think we have to somehow absorb that into our standard deviation. This is what I think.
Yeah, I also.
Yeah, go on. Rachel may have something about the paint variation.
I can chime in. So during our process, we aggregate and blend, and whilst we do receive, as you can imagine, some paint that has been sitting in people's sheds for some time, because it's only when they move house or something happens that they decide to return paint. It's one of those things people like to sit on for a very long time just in case. But we batch at the moment in our pilot plant 1,000 litres. So you do get a really average mix of what we receive through the scheme, which is a combination of interior and exterior paint. We perform inbound QC and outbound QC because we do have a range of solids content, viscosity, and even colour for some applications. So we do control it in that way. Some applications that we're pursuing are a little bit more stringent than others. So yeah, we do have different specifications for different products depending on what we receive and aggregate and mix on average. But it tends to be pretty stable in terms of what we get. You know, it's not as narrow as virgin paint, but it's fairly close.
Yeah, I also have a couple of questions on because you discussed about open porosity and the closed porosity, and having it as a closed porosity allows us to have more carbonation resistance in the sense. So does having a closed porosity, my question is like, having a closed porosity reduce the weight of the concrete? Can we consider this as a lightweight concrete, low dense?
That's yeah, but we are only looking at very small percentages. See, when we're looking at lightweight concrete, we want a significantly higher amount of air. This one is only very small, so it matters to carbonation and stuff because we're looking at porosity, open porosity, but 7%. So we're looking at, say, 20% total porosity, open porosity, half of that. So ideally, if we can have concrete with all closed porosities, it'd be a lightweight, carbonation resistant concrete. But I think that perhaps one day we can achieve that. But at this stage, it's not.
Yeah. So can we look at it as an air entrainment agent, which?
Yeah, I think Paintback was thinking about that at the beginning, but I kind of discouraged them because air entrainment agents are very cheap in concrete admixtures, and they want to precisely control the air. So you know, if the paint variation and the air, you cannot control it. So, and the other is there's not a lot of air entraining applications in Australia. I mean, it's people use it for frost resistance and so on in North America and Europe, but not a lot. Yeah, Rachel, you were going to say something.
No, I think you've got it in hand, Jay. Thank you. Jay's very good at counselling us in terms of research direction, and I think we moved away from the idea of it just acting as an air entrainment fairly early on because it is achieving that, but I think it has interesting benefits beyond that.
There's another question.
Is, can you predict any potential cost impacts to concrete containing paint?
That depends on whether Paintback give it for free or whether they want to charge.
You put the ball on your court, Rachel.
So I guess it's a bit of a misnomer that a not-for-profit, you know, gives everything away for free. So essentially, we do need to recoup costs around operations, but also processing, logistics, treatment. We do have input materials as well into our processing. Even Jay was mentioning the potential use of defoamers to get the air under control, but to still yield the same benefits. So we do have, you know, cogs in, so we would look to recover those costs, but again, we wouldn't look to make it more expensive in terms of a finished product. It would be cost competitive.
And also you have to supply a somewhat consistent product. So that requires some work. Yeah.
Yeah, and hands on deck. So we do have people obviously working in the plant. I myself am working the plant today, so we do essentially have a labour cost line as well.
I have a quick question for you, Jay. Obviously working for a cement manufacturer, I see a lot of alternative SCMs coming through, and you shared some data, and thank you for sharing that again, in regards to as you increase the amount of reclaimed paint, your water per cubic meter actually decreased quite a bit. So I think it was around 144. The question I have for you is, how did that impact, I guess, the plastic properties of the concrete? 144 is quite low, so I'm really curious as to what you saw. So I think if we introduce more new materials into concrete, people will always question, what will that look like? Will it change the plastic properties and things like that?
Yeah, that, it's a bit low. So I'm not quite sure what the question is. So those we just pick one particular mix, but those mixes can be changed. But when we add the water-based paint, it introduces a lot of air, so we can pull some water back. But despite that, we are losing strength. Now, when we're introducing supplementary cementitious materials, regardless of what the supplementary cementitious material is, it's going to increase carbonation. That they found with the calcined clay, they found with fly ash, slag, limestone. So we are under pressure to put more and more supplementary cementitious material, and we are coming up with calcined clay. This is a new one. Fly ash slag's been around for a long time, but it's going to increase carbonation. So I think that is the pitch we're putting on now about the carbonation. Now, plastic properties, because we did not have, it's a low amount of water, but the workability is the same, 80 slum. Whether that introduce plastic shrinkage is too early for us to look at those issues. Then that will depend on the application. If you are putting it in columns, it's not a major issue, but if you're doing slabs, plastic shrinkage is an issue. So those are subsequent issues that we need to look at, but at this is early stage at the moment.
Before we let you go, I have another question. The regulatory framework and the standards that come with it, and the difficulty in getting this product into the market, where do you see? I think it's a common question for both. How difficult, maybe say it rate from 1 to 10, how difficult do you see this idea is in getting to market?
I don't think it's hard to put a quantify. I want to say 10, but it's not really 10. It's more of a time cost rather than a challenge. It does take time for us to receive the relevant EPA approvals in each state, which does make like commercializing something on a national scale quite challenging. And then I think Jay could probably talk more to the standards and performance spec side of things.
So the standards, this comes as a polymer additives. So I don't think there's an issue with the standard because it will comply with. We just have to comply with all the performance requirements. The main issue is the willingness of. Is the commercial. Is there a commercial benefit? Because when the concrete, when they have to add an extra material, there's a cost because they have to have another plant, another mixing and blah, blah. But is that justified? The benefit justifies do we have to bother with this is there a benefit if you have to bother with this additional material? And there's an answer that has to come from the industry. I mean, we are hoping they'll take it up, but it's more, I think we would like to hear from the audience what they think. Is the carbonation resistance that you see, is that enough? Maybe somebody in the audience can, who are in the concrete supply industry or concrete specifiers, if a major project where they have difficulty achieving the carbonation with increased supplementary cementitious matter, would they specify? I mean, this is a question for them, because we think it's a very good idea, but because it's us, we are doing the project. But it'd be good if.
Yeah, I have a question. I think before we discuss on that, so Rachel, would you be able to tell us like the global standing, like the where the technology is in using the reclaimed paint globally?
It's a good question. There's precedence of it being used internationally. So in New Zealand, I know there is batching plants that utilize paint as a replacement for a couple of their admixtures. In terms of integration with batching plants, it's not really that challenging. We would need just a similar setup, like a constant agitation, or at least an agitation to prevent paint from settling, because paint's really good at settling. So yeah, there is utilization, I guess, in lieu of having strong policy carbon levers in Australia. I think adoption may be a bit more challenging. People seem to find comfort in the status quo, but there would be there would be a demonstrable carbon benefit if that's something that a project or a batching plant or a supplier is seeking. But this isn't, that out there. There has been paint placed in concrete and has held up, through time. So we're just trying to push the limits and see what an increased dose does to the benefits.
That's fantastic, and we are unfortunately running out of time. Thanks audience for all the questions. We want to continue running this as a conversation more than a webinar. We keep repeating this message, but that's all for what we have time for today. And thank you, Professor Jay and Rachel, for speaking and sharing your thoughts around this great topic. All the best for the rest of the research and trying to get the correct industry partner to scale this up and getting into the construction industry. And for audience, if you have any extra questions, if you think about a question later on, you can always follow up questions with SmartCrit. Natalie shared the SmartCrit email in the chat below, so always reach out and we'll try to get the answers from the presenters to you directly back to you. That's it from us today, and thank you for being a great community, and enjoy the rest of the day.